How can a machine no larger than a city bus generate enough force to lift hundreds of tons into the sky? Every day, jet engines produce extraordinary amounts of thrust with remarkable reliability. At first glance, it appears to be nothing more than a giant spinning fan. But hidden inside is one of the most sophisticated machines ever built. And one hidden process transforms ordinary air into massive thrust. What exactly pushes a jet aircraft forward? Is the engine simply throwing hot air out the back? And why does moving air create so much force? The answer begins with how air moves through the engine. To understand thrust, we first need to understand airflow. Most people imagine jet engines as controlled explosions pushing aircraft forward. That assumption seems logical, but it is only partially true. In fact, most of the thrust in a modern airliner comes from moving air, not burning fuel. The giant front fan does far more work than most people realize. And that changes everything about how modern jet engines operate. The first hidden mechanism is the fan. These enormous blades accelerate huge volumes of air every second. Once inside, the airflow divides into two separate paths. Most of the air bypasses the combustion chamber entirely. Surprisingly, the largest source of thrust is often the air that never touches the fuel at all. But moving air is only the beginning. The next hidden system dramatically increases its energy. Inside the engine, rotating compressors squeeze incoming air into a smaller volume. As pressure rises, the air becomes hotter and more energetic. By the time it reaches the core, the air is compressed many times beyond atmospheric pressure. Now the engine is ready for the process most people associate with jet propulsion. Fuel is injected into the compressed air and ignited. But unlike an explosion, the combustion is carefully controlled and continuous. The goal is to create a steady stream of high energy gases. Those gases now contain enormous amounts of energy. The next hidden mechanism captures part of that energy before it leaves the engine. The turbine acts like a windmill operating inside a hurricane of superheated gas. Through a series of shafts, the turbine powers the compressor and the giant front fan. Now imagine a dangerous scenario. What happens if airflow through the engine becomes unstable? Under abnormal conditions, sophisticated systems monitor and protect the engine. Modern jet engines constantly measure thousands of parameters every second. Long before a serious problem develops, protective systems intervene automatically. Here's the surprising fact. A modern turbofan generates most of its thrust not from fire, but from accelerating an extraordinary mass of air. What appears to be a giant spinning tube is actually a highly efficient energy conversion machine. Every stage transforms air, pressure, heat, and motion into the force that lifts aircraft across the world. Now you know how jet engines produce massive thrust. What machine should we explore next? Subscribe to Hidden Mechanics Lab for more engineering secrets.